Okay, first video for chapter 22. So now we're going to be making inferences about our means, our population means instead of our proportions. So a lot of this is going to look the same. The only thing is that you're now going to have different formulas, and our distribution, which is going to be the major difference, is going to be slightly different. So the first video is mostly background, talking about that difference in distribution. So we'll start, of course, with estimating our population mean by using we'll be finding confidence intervals for a population mean. So we'll use a familiar formula. It's the same formula. It's our estimate or our statistic plus or minus our critical value times our standard deviation of a statistic. Okay. So you will see that we'll use the same formula that we have in the past. The difference here is going to be, this is now your standard deviation formula. Okay, this is for a sample mean, not a sample proportion, so of course that changes. Okay, the other thing that is going to change, and we will talk about that momentarily, is the idea of using a z-critical value. So we will still be using a critical value, but it's not going to be a z-critical value anymore, because we're going to see that our means are not actually normally distributed. And then the biggest thing comes with our standard deviation. So in order for us to find our confidence interval, we need to know what our standard deviation of our population is to find our standard deviation of our sample. Of course, we don't know anything about our populations for our confidence intervals.
John Cannon, would you please dial extension 3104? John Cannon, would you dial extension 3104?
Sorry about that. So much like we've done with our proportions, we're going to have to use, instead of our standard deviation for our population, we're going to have to use our standard deviation for our sample. And so we run into the same thing where it's not actually our standard deviation, it's going to be our standard error. We'll talk about that again in, I believe, the third video. But I want to talk more about the idea of that critical value no longer being a normal distribution. It's not a z-critical value anymore. So in order to find your z-score, we take our statistic, we subtract our parameter, and we put it over our standard deviation. Well, of course, we already just said what happens.
Jen Beatty, would you dial extension 3104? Jen Beatty, 3104, please.
Apologize again. So what happens when we don't know our standard deviation? What happens is that we end up with a different formula where we have to use our standard deviation of our sample. Now, this may seem like it's a minor thing. Of course, with proportions, it didn't really affect us, but with the means, it does, because what ends up happening is that our new statistic does not have a normal distribution. And so this is not going to be our z-critical value. It's actually going to be our t-critical value. So we will see that we have our statistic, our standard deviation for our sample has a new distribution, and it is going to be called our t-distribution. So it is a bit of a different shape than our normal standard curve. It is symmetric, and it will have a single peak at 0. However, it's going to have much more area in the tails. So if you take a look, these are two examples. I'll describe these further in class with you. But this would be a t-distribution. So here's your sample means as opposed to your population means. So notice you have a lot more area in your tails, making it, it's not normally distributed. So we call it a t-distribution instead. Like any standardized statistic, t tells us how far x, our sample mean, is from its population mean in standard deviation units. However, there is a different t-distribution for each sample size. We specify a particular distribution by giving it its degrees of freedom. Okay, so this brings in another idea. It's a lot of background here, guys. Not so important for your calculations, but kind of where these formulas are coming from and where these numbers are coming from. So I just quickly want to talk to you about the degrees of freedom. So they are going to be found by, this is not the slide I want. I'm going to come back to that. They are going to be found by taking your sample size and subtracting 1 from it. Okay, we will write the t-distribution with n minus 1 degrees of freedom as t to n minus 1 for short. This is shorthand. Okay, so what are the degrees of freedom? I like to think of the degrees of freedom as wiggle room. So kind of just in a nutshell, when you're finding your sample standard deviation, we have to use our sample mean because we don't have our population mean. So this is obviously going to create a problem because in any sample, the data values will generally be closer to their own sample mean rather than the population mean. So when you calculate the standard deviation with the sample mean, not the population mean, your estimate ends up being way too small. So we fix this problem of your estimate being too small by using n minus 1 degrees of freedom. So it just fixes the problem. It has to do with why in the beginning of the year we were doing standard deviation, we divided by n minus 1. I'll make that connection again in class. Your textbook does a good job of explaining this further, and that's on page 577 to 578. Well, that didn't help much.
Christina Olszewski, if you're in the building, which dial extension 3104. Christina Olszewski, extension 31043.
Okay. So one more quick slide and we'll be done with this. So when comparing the density curves of the standard normal distribution and t-distribution, several facts are apparent. So the density curve, so here's just here's 3 rather distributions. So you have your standard normal curve. In purple, you have your t-distribution with 2 degrees of freedom and your t-distribution with 9 degrees of freedom in that bluish color. So the spread of the t-distributions is a bit greater than that of the standard normal distribution. The t-distributions have more probability in the tails and less in the center than does the standard normal. As the degrees of freedom increase, the t-density curve approaches the standard normal curve ever more closely. And that's it for your first video.